In the previous videos, we mentioned about the data collection plan. This data collection plan is an extension of your research design as derived from the flowchart indicating the process and stages of your research. It provides a more refined details at the planning stage for you to have a better idea of how your research are going to be. It is important for you to know the purposes of each stages of your research, and then you have to work out as refined as possible in terms of the details, how those are being conducted. You will need to know the set of data that you are looking for, what kind of methods that you're going to use, is there any instruments involved, and you will have to check the availability of those instruments within your institutions. If you are lacking of certain instruments, you have to find your ways to acquire those, either to purchase those if you have sufficient fund, or to rent those instruments from the other institutions if they provide this kind of services, or you might need to outsource part of your testing program to the other institutions in order for you to acquire the relevant results. You may also redesign your study working within the boundaries of the facilities that is available in your institutions. This is for you to realize your research study from the planning to the actual study. You might need to clearly define the operational definitions, sampling parameters, precautions measures, as well as the baseline. These are the things that you can actually plan ahead, which later will serve as a guideline to you in carrying out your research study. You might need to think of all the possible challenges that you may going to encounter as you simulate through this process in your mind, any possible problem, and by all means try to resolve it in advance to prevent any hassle that occur when you are actually conducting those studies. A good planning for you, it will help you to complete your research within the stipulated time, and your research process can be conducted smoothly without much interference by the unexpected events which may finally affect your deadlines of your submissions of your thesis. This is it in terms of the data collection plan. Now you can actually look into deeper in terms of the data's results, which are commonly known as the variables that involve within your research study. The data collection plans give you an idea how the research is being carried out at different stages of the studies, and this planning for the variables will give you an idea how you intend to analyze and process the data for you to acquire findings from your research study. Taking this as an example, which is an extension from the data collection plan as well as the flowchart as developed for a research study. Now you have three objectives here. The first two objectives, it will be experimental study, and the third objective, it will be analytical modeling. Therefore, in terms of the sampling method, your first two objectives, it will be purely experiment, and your third objective will involve analytical modeling plus verifications with the experimental results. You also want to know what type of the studies that you are conducting, whether it is qualitative or quantitative, which in this case it is quantitative study. That means it's involved a lot of measurements and these measurements will yield data, and then those data are later being computed into results, and then those results are evaluated and interpreted for you to acquire the understanding of the subject that you are studying in the process of fulfilling the purpose of that particular study, which ultimately going to attain your objectives. Next, you will need to determine the manipulated variables. These are the variables that you can control while designing for your specimens. You will need to control some variables so that you can make direct comparison among different specimens in order for you to observe the effects of each parameters. Normally, there will be fixed variables and also changing variables. The fixed variables are the variables that you have set, where all the specimens will follow the fixed variables. They are homogeneous in terms of the variables as identified in the fixed variables, which in this case, the locations of the point load, the amount of reinforcement bar provided, the dimensions and size of the beam, the effective length between the supports of the beam. These are the fixed setting for the specimens. And then there will be changing variables. Let's say now your objective 1 is looking for the design which will give you best results. Then you will have to redesign the specimens. Every specimen with different design, following certain changing patterns of the variables, which in this case is the diameter of PVC pipes and also the positions of the PVC pipe in the beams changes. This will be the changing variables. By observing the changing variables within the specimen set, you may evaluate the performance and you will know the effects of these variables onto the performance of the specimens. Let's say now your objective 2 is meant for the parametric study. There will be a set of fixed variables again, and then now you change the variables, such as in terms of the spacing of the PVC pipe and also the hollow ratio due to the void created by PVC with respect to the cross-sectional area of the section. Then for your objective 3 for the analytical modeling, the changing variable can be the system combination case, which is depending on your research setup. Now you would like to look at the responding variables. These are the data that you're going to acquire during the testing. Having all these variables set within the specimen, now you put the specimen to the test. There will be measuring instruments installed. You will have to acquire the loads, displacement, as well as the failure mode during the experiments. These responding variables is actually responding to the manipulated variables. If you change any of the variable here, your responding variable shall change as well. Therefore, technically, the responding variable is actually governed by the changing variables. Then most likely you have to derive the variables for the computations of the results. The data represent the measurements as acquired from the testing. These data themselves can be the result, and these data can also be processed in order to acquire new results through some computation process. And these derived variables will be the outcome of the processing of the responding variables. It is considered the second layer of the variables after the responding variables. Having this derived variable acquired, now you have more information regarding the specimens for you to have better understanding in terms of the behavior of the specimen. Let's say now you have acquired the load data and displacement data as well as the failure mode. You know that if you find the relationship between the load and displacement, over the time you will acquire a load displacement curve. And this load displacement curve, through a processing process, you are able to find the gradient, find the turning points, find the highest point, and so on so forth, for you to acquire the mechanical properties of the specimens. The gradient will represent the stiffness of the specimen. The turning point will represent the yield strength of the specimen. The highest point of the curve will represent the ultimate load, and the corresponding displacement at the ultimate load, it will be considered as the ultimate displacement. And then you may use some formulas based on the test setup for you to calculate the bending moment and the shear loads acting within the member. And this computation process will give you derived variables in terms of the bending moment and shear load. Also, you might want to look into the efficiency evaluations based on the ultimate loads that you have acquired with respect to the design of the specimen. For example, the hollow ratio. Then you are able to determine the efficiency ratios of the specimen. How efficient is the material used within the specimens in resisting per unit load acting onto the specimen. You might have verification process for your objective 3, which there will be comparisons of the experimental result and the predicted result from the analytical model. You may put these two results together in division form to give you the reliability ratio. Then you will know that how much differences between the experimental result and the analytical results, for you to have an idea how accurate is the result and how reliable is your analytical models. You may also use the mean and the standard deviations for the reliability ratios to give you an idea how accurate is your predictions in terms of the analytical model, where is the mean, whether your analytical model overestimated or underestimated the actual response. You can have more derived variables, which is dependent on the purpose of your study, as well as the degree of understanding of you from the data that you acquire from the study. And then later, for your discussions and interpretations, you will refer to both the responding variables and derived variables with respect to the manipulated variables, for you to identify which design is better, or probably give you some ideas how to acquire the best and optimum design for your specimens.